Okay, so let's back up here. Properties of equality. We're talking about numbers and measurement and equal signs with these properties of equality. So any kind of algebra that we're having to do to solve, we're going to use these properties of equality. And then, so today we're going to actually have to write which one we're doing. But we'll try to abbreviate as much as we can. Just kind of shorten things up a little bit. Yesterday we didn't have anything else to mix in there. So we'll mix in these properties of congruence, and they have the same names as some of those properties. So we got to be careful of that. And then the symmetric property of congruence means if we've got two segments in this case that are congruent to one another, then the symmetric property does what? Flips it around so that CD is congruent to segment AB. And notice that, they have the notation for the object that they are. So these are talking about objects, not talking about the measurements of those objects. Okay. Transitive property, remember that from yesterday, it had the three pieces in it. So we'll have three segments here. Segment AB is congruent to segment CD, and segment CD is congruent to segment EF. Then that means that segment AB is congruent to what? EF, yeah. So congruence properties, we're talking about objects again. I keep mentioning this is going to be big. So when I grade proofs with this, you got to be the right stuff here. So definitions of congruence. This is where we get to stop talking about objects and then talk about the measurement of an object. Okay. So with segments, if segments are congruent, so segment AB is congruent to segment CD. By definition, we know that if those are congruent, then they have the same length. So AB is equal to CD. So that lets us, I've always kind of used this thing, it lets us take their hat off and do some work with it. Okay. So we take the object notation off and start talking about their numbers. Okay. So we can use equal signs, which that opens up all the algebra stuff out of that. The second thing is what's the property, or what is it when it swaps the if and then?
No. Converse. No. Yes, converse.
Converse. So the converse is to take AB is equal to CD and then get the congruence out of that. So the converse of that. So definition of congruence allows us to talk about, instead of objects, talk about measurements, or the other way around, stop talking about measurements and talk about objects. So that's going to be one of our reasons that we would use to talk about proving something there. Definition of midpoint is the midpoint of segment divides a segment into two equal or congruent parts. If M is the midpoint of AB, then AM is equal to MB. Is what we get there. Definition of midpoint. If M is the midpoint of some segment AB, then A to M is the same length as M to B. That's what we get. So definition of midpoint is going to be something we use some here. Okay. And then the last thing is the segment addition postulate. So this is our first real postulate that we've talked about. And A, B, and C are collinear points. And B is between A and C. All that is doing is describing that picture and telling you what points are on the ends and what's in the middle. And then what happens from there? So what happens from that is the segment addition postulate says AB plus BC equals what? AC. Obvious things we know, but it's a postulate. It's a rule of geometry that that has to happen for other things to be a result of that stuff. So segment addition postulate. All right, so let's we didn't call this one name that property. Y'all made fun of that yesterday. It hurt my feelings. So
I didn't make fun of it. I like to say it.
Yeah.
It had an
Sure,
exclamation mark,
sure.
so you had to say it with
Sure,
enthusiasm.
crawfish on it now. All right, so let's get the properties. You got a bank at the bottom of your page there. That's where we're going to. I didn't want to put it up here. So PQ is equal to PQ, then segment PQ is congruent to segment PQ. The what now? Definition of congruence. One is measurements, one is objects. Reflexive would just be, which one is reflexive? 3 would be the reflexive property of congruence. Definition of, and we'll use the symbol congruence. That'll gonna kind of try to help us shorten up our reasons here using some notation here. Number 2, if K is between J and L, and JK plus KL is equal to JL.
Segment addition.
All right, segment addition postulate. And we'll just write segment addition because there's no other segment addition property or things going there. There's a postulate that we know. Segment addition. What that means. Number 3 is that reflexive property, and we'll abbreviate property of congruence. You don't have to write it all the way out.
You have to put congruence.
You will today because we're talking about because we've mixed in objects and then measurements. So you may have times where you're using the reflexive property of equality, or other times where here you're using an object, so you're talking about of congruence. So be clear about that. I know it seems like it's nitpicky. It is. We're doing proofs. It's nitpicky. All right. If RS is equal to TU, then RS plus XY equals TU plus XY. So these are these objects or measurements? Measurements. Why can you tell that?
Because they're adding.
They don't have the line over. It doesn't have the notation to say we're talking about an object. So if we're going to do addition, what are they adding on each side? XY, they're adding the same thing on each side. So what property is that? Yeah, addition property of equality. And you just use an equal sign there. Because we're doing measurements, not objects. Number 5, AB is equal to DE, then DE is equal to AB of doesn't have the hats on it, doesn't have the object mark on it, so there's really just measurements, so numbers. Number 6, if Y is the midpoint of segment XZ, then XY is equal to YZ. Ooh.
I have no idea what it's called.
Say it again. So who said definition of midpoint? Good job. As a result of the definition of midpoint. And just midpoint. It's not perfectly the same thing as what the definition of midpoint said, but it is yeah, that's a big clue. All right, 7 there. Transitive property of congruence. Congruent symbol is just equal sign with a little squiggle above it. Number 8. Is it? It's addition property because what's the if? The hypothesis here has the plus on the same addition on each side. It's the converse of the one we did earlier. Well, it adds more stuff to it. And as we get into more stuff, the more things it adds. So it's a little tougher. So yeah, of equality. Because it doesn't have congruent marks and it doesn't have segment markers. All right. Number 9, PQ plus RS is equal to TV, RS equals WX, then PQ plus WX equals TV. Absolutely, substitution property. Good job. And we'll just do it. Okay. 10, LP is equal to PN, and LP and N are collinear. If P is the midpoint, then P is the midpoint of LN. Yeah, the only thing we have is the definition of midpoint. Anything that talks about midpoint, reflexive is LP equals PN, or LP equals LP. PN equals PN, that's reflexive.
But if you say like the measure of LP equals the measure of
No. Reflexive has to have the exact same thing on each side. That's so when you look at 11, you're talking the hypothesis has the objects, and then the conclusion has the measurements. Definition of congruence on this one, because those are not the same things. It looks like reflexive, but it's not the same things because this is objects, and then these, the conclusion, are measurements. So this would be definition of congruence. There. And then number 12, last one. All right, let's try to do a few proofs here. And as Tilly said, this is a little tougher than yesterday's, but we're going to kind of ease you into it. And
Is it still given on one?
is it?
Oh, yeah, it is.
Yeah, the look at our given is E is the midpoint of DF. So number 1 is the given part. So that one is the free one. So how do we get DE equals EF? Yeah, it's a definition of midpoint. They told us in the given something about a midpoint. The next line should be something that deals with that midpoint, some sort of result of that. And then what's going on here for number 3? Okay, the addition property of what? Yeah. So on the left side, we have DE plus DE, and then on line 4, it says 2DE. Yeah, just simplifying. That's all they did. They put the like terms together. Instead of having X and X there like we did yesterday with the algebraic proofs, DE just represents the length of segment DE in our picture up here. It represents that length. We don't know how much it is, but we know that, you know, if it's X and this is X and you add them together, it's 2X. Same thing with the DE. It's 2D. So segment addition, because DE, look at your picture here. You got DE is right here, and then EF is right there, and together those two make up the F. So that is segment addition. Now, from 5 to 6 takes line 4 and 5 to get. Look at line 4. 2DE is equal to DE plus EF. Line 5 says DE plus EF is equal to DF.
They're all the same length, so 2DE is just like saying DE plus EF equals DF.
So what property gets us here? I'll try to let you guys say it louder, Faye. The transitive property, because we're taking 3 different things. We got 2DE is equal to DE plus EF. Here's DE plus EF is equal to DF. This is equal to this, and this is equal to this. Then these two got to be equal to each other. So transitive property. Yeah. Do what? Go back to the algebra phrase. No, you don't. So yeah, not a little bit more thinking involved here. You got to really pay attention line by line about what they're doing, and just realize. And I think the biggest hurdle to jump here is realizing that when they talk about measurements of segments, think about those things as the same thing as variables. So DE, you can call it X, and EF you could call Y or something like that. So think about them in that way, that they're just variables. They just look different because of the way we're naming them. Let's look at number 2. This one's a shorter one. Hopefully it makes it less painful. Segment KL is congruent to segment LN, and segment LM is congruent to segment LN. So here's what's happening. They're all congruent to one another there in our picture. That little slash through those lines means they're congruent. So number 1. Yeah, good job. Yep. All right. And then what did they do from number 1 to number 2? Yeah, they just took the object part off of it and just did definition of congruence. And then how did we go from 2 to 3? KL is equal to LN. But how did we get there from the second one to the third one? Well, it's the transitive property. And then if KL is equal to LM, how does that? Yeah, that's the only thing we have about midpoints is the definition. As you do more of these, you're going to get more familiar with what they look like, which we got a lot of examples today, so help you get kind of an idea of that. All right, number 3, longer one, 7 steps here. They've given us all the statements. We've got to get the reasons for this. So eventually we're going to get away from we're going to have to come up with our own statements and reasons. So the first one is bestowed upon us. It's given. So in this picture, it says that PQ is congruent to TQ, and that UQ is congruent to QS. So I'm just marking my image that way so that I know what the statement said. Okay. So if PQ is equal to TQ and QU is equal to QS, that's what line 2 statement says. How did they get there? Yeah, definition of congruence. Okay. And then number 3, look at the prove statement. We're trying to prove that this entire segment from P to S is congruent to T to U. Okay, so that's what we're trying to build up here. So at step 2, they were just getting the definition of congruence so we can talk about measurements and then do some math with those. So number 3, they take PQ plus QS. Where's PQ and QS? It's on one line. It's all the same line, right? And that adds up to be PS, which is one of the pieces we're trying to get a proof statement on. And then on the second part of that, they took TQ and QU, which makes up the segment TU. Yeah. All right. And then it says TQ plus QS is equal to PS. TQ. Okay, what else was equal to PS? Yeah. It was PQ plus QS. Yeah. What's changed here?
There's not a PQ.
It's instead of PQ, they have TQ. How could they do that? Substitution. And maybe over here in the parentheses we'll write, we said we knew that PQ was equal to TQ. And that's how that happens. That's not something you would have to do on a proof there, but maybe here in our notes while we're learning to do this, that helps us know where that came from. Okay, and then number 5, you've got TQ plus QS is equal to TU. What else was equal to TU? These two added together. So it had TQ and QU, now it has TQ and QS. So what did they do there? They substituted again. And that was because QU was equal to QS. We had that in step 2. That was where they were getting that from. All right. Now, number 6, they jumped to PS is equal to TU.
Well, that would be transitory, right?
Right, because we're taking these two things are equal to 2 different things. So that's 3 pieces. And now we can cut out the middleman and get PS plus TU. So that's a transitive. And then the last step is instead of talking about the measurement of PS and the measurement of TU, they talk about the object segment. Definition of congruence, because we're going from measurements to objects. And they're instead of equal, they're congruent now. So that's a definition of congruence. Anytime you're going from objects to with a congruent sign to an equal sign and no hats on the things, that's going to be a definition of congruence thing. You're never going to change up in the middle of things, right? Not always. Depends on what you're given with to start with. If you're given objects, then yeah, most likely it's going to be some sort of definition out of that. If you're given objects and you're given. If you're given happen to be measurements instead of objects, then no. But if you're like here, you're given an object, then most likely you're going to do some sort of definition in the next step out of that. Good question. All right. Let's try 4. A different looking picture here. It says K is the midpoint of JL and M is the midpoint of LN. And they also say that JK is equal to MN. So here's an example of that, Ryan, that here in this statement, the given statement has some objects in it, and then it's also got some measurements in it. So that could change things a little bit. It's got a lot of information, though, out of that. So K is the midpoint of JL, and M is the midpoint of LN. That's only part of our given statement, but that's okay. It was still given to us, right? Yeah, it's given because it was just part of it. We're not using all of it yet. We may need this other part in just a minute. Okay? Because we know K is the midpoint of JL and M is the midpoint of LN, then JK plus KL are equal, and LM is equal to MN. Yeah, that's a definition of midpoint. So here we use the part of the given that was about objects, and yes, our second step ended up being a definition. So we see that connection there. So yeah, most likely. And then number 3 says JK equals MN. Where'd that come from? It was in the given. So that's the reason. So look at statements 2 and 3. We got JK is equal to KL and LM is equal to MN. So step 3 says you got JK is equal to MN. Okay? So we got a JK is equal to 2 different things here. And then statement 4 says MN has got to be equal to KL and LM has got to be equal to MN. So that would be, it's kind of there's a thin line here between what's going on, because step 4, we're not doing really transitive property because we're using more than just 3 things, right? Transitive property has to have this, A is equal to B, B is equal to C, A is equal to C. Here, our statement has more than that going on. It's got A is equal to B, and then we don't have anywhere it says that B is equal to C yet. So that MN equal to KL, that's coming from taking JK and replacing it with MN. And LM is equal to MN. We'll replace that. That's already there from the definition of midpoint. So I think this is more of a substitution in my view of that. I probably wouldn't count it wrong if you wrote transitive there, because it's really, really thin line between those two as to which one it is. But I'm going to say that it's a substitution because we have more stuff on that line than what transitive normally would have. And we're substituting JK and MN. That's where that's coming from. So I'm just writing that out in parentheses there so we know what we substituted. The next one for sure is transitive, because now we can say that LM is equal to KL because we have 1, 2, 3, and the MN is still part of that, and now we got those 2 end pieces there. So that would definitely be transitive. And then it says KL is equal to LM. Yes, because what does symmetric do? Turns it around. Yeah, flips it around. Symmetric property. Yeah, and the last one, changing from measurements to objects, is definition of congruence. Experience is really a big key to this. The more of these things you've done, the more the same thing kind of comes up over and over. There's only so much you can do with a segment. But the proof of it is a little tough sometimes. Let's go ahead and do number 5. We may just do a work day tomorrow and just do all these proofs together today and let you work on homework. I'm sure y'all won't mind that. Because it is a little bit more difficult than yesterday's stuff. No question. All right, so segment XY is congruent to segment UV, and segment YZ is congruent to segment TU. So they're telling me this stuff, and I'm gonna mark it on my picture. Not that you have to do that, but I think it just helps me kind of see what's happening and know, okay, this is what I'm supposed to be visualizing when I'm doing my proof. A picture really does help. It's geometry. It's about shapes and parts of math. So pictures help. All right, so we're going to use that picture not as a way of proving things, but a way of getting what we need. So number one, yeah, we don't even have to think about that. It's always going to be given. And then what they do in number two. Yeah, definition of congruence. We took the hats off, made them measurements instead of objects. Number three. You don't have anything about midpoint. Segment addition, because we're saying, okay, XY plus YZ, that makes up this segment XZ in our picture. And then TU plus UV makes up this segment TV in our picture. So that's just segment addition postulate. Okay.
Would that not be the same thing?
There's a lot of answers going in there. How's it substitution? Tell me what we're substituting. XY and UV. So we go from, look at the two lines. You got XY here plus YZ. On the next line, you got UV plus YZ. So that's where you see the substitution coming in there. So substitution and XY equals UV. That's the substitution that we're using. And then, we also did TU and YZ. So I guess I need to write that down too. Number 5, is that what you're saying? Yeah, transitive is number 5. That's right. Yeah, absolutely. There you go. You're getting better at this. Not bad, not bad. Oh, no, bless you. Spell segment. M-E-N-T after that. All right, number 6. So we got a picture here that says that YW is congruent to YZ, or YW is congruent to YZ. So this is congruent to this, and then XY is congruent to VY. So those two are congruent to one another. So number 1, I'm not even going to ask. Number 2, I shouldn't have to ask, right? Definition of congruence. We just took the object off. XY plus YZ is equal to XZ. Yeah, so that we built the larger segment. And then
Same thing, right?
Is it?
No, it's substitution.
What do we substitute?
The last one. No, you said yeah. Wait, you're adding
I substituted both of those to get XZ, right? We did. We only substituted. We can only do one step as far as moving things around, but replacing things, we can substitute. Since we have a statement up here that has 2 things in it, so it's just like distributed. Yeah, that's kind of the idea. Yeah. Substitution, we're substituting x, y, and excuse me, vy. Or back up. XY, yeah, XY equals VY and YZ equals YW. Those are the things we substituted.
The next one would be segment addition, right? Because it's half of the line.
Yeah, because it's the other segment. We had to build it. So segment addition. Number 6 is transitive. Good. Yeah, and the last one is definition. That's the one thing I know. Okay. So far, they've been giving us all of our statements, and we've been coming up with all the reasons. So now we're going to start mixing that up, and we're going to have to come up with some of our statements and some of our reasons, and try to build up to where we have a completely empty box, and we got to fill it all in. Okay. So.
Well, I've already figured out 2 of them. 1 is given, and 3 is DE equals EC, because it is given too.
Okay.
Yep.
All right. Let's get number 2 before we get to number 3, though. All right. E is the midpoint of AC. So what would definition of midpoint tell us? Yeah, AE equals EC of that. No, definition of midpoint allows us to go straight to the measurement there. And then 3, yes, is that DE equals EC. Well, the statement says EC, so that's what I'm going to use. And then statement 4 says AE is equal to DE. How? Transitive property. Good job. We got 3 things. We have AE is equal to EC, and DE is also equal to EC. So that must mean AE and DE are equal to one another. That's how the transitive property works. And then because AE is equal to DE, those objects are congruent. So segment AE is congruent to segment DE, but our proof statement wasn't in that order.
So it's
Symmetric property of congruence. What allows us to turn it around there. It might be not as bad as we thought it was going to be. You'll get there. It just takes practice. This experience is the key to a lot of this, very, very much. So. All right. Kudos there. All right. RS is equal to 1/2 of RT. And say that again, Haley. Yeah, because how did we get from 1/2 RT to 2 RS? You multiply both sides by 2. This is the math that's happening to get it there, right? To get RT by itself. Because we're trying to prove something about the object RT with S being the midpoint there. So 2 RS is equal to RT with multiplication. Yeah, it takes me a minute. I'm sorry.
Okay,
What is number
RS plus SK equals RT.
Anytime you're building a segment up, it's segment addition postulate.
Now, is this one substitution?
Why is it substitution, not transition?
Substituting 2RS for
I'm so. Yeah, or you're substituting, yeah, 2RS for RT. That's fine. Yeah, that'll work.
Wait, I'm confused on that one.
So we're right here.
So where did the other RS come from? The RS of the.
All right. From statement 3, this and this are the same.
Yes.
From statement 2, this, both of those are equal to RT, right? If you look at the.
Okay, and RS plus SC equals RT. Okay. Yeah.
All right. So substitution. Let me go back to writing. And we were substituting 2RS and RT.
Keep your feet still. Okay, that's the only. Transitive, yes.
Transitive. Or no, not transitive. Think algebra.
Algebra.
How do you make a 2RS? Look, what are like terms here? This is RS and this is RS, so I gotta subtract RS from each side.
S is the midpoint of RT.
Okay, so that, yeah, because it's the proof statement of it. And definition of midpoint. So there we got RS is equal to ST, which is what the definition of midpoint does say about segments. Okay. All right. And here they're only using part of the given. They're only using part of the given here. They're using the top part, M is the midpoint of LN. And then number 2 says LM is equal to MN by definition of midpoint. Number 3 is the second part of the given. N is the midpoint of MO. Yeah. What are we trying to prove? We're trying to prove that LM is or segment LM is congruent to segment MO or NO, excuse me. So transitive
would be
okay. Transitive property takes step 2 and step 4 and puts those together. 1, 2, 2, 3. So there's that transitive property going from LM to NO. So that gets us the 2 measurements equal, which if the measurements are equal, put the hats back on them. And we made our way out of that.
Oh, Mom.
All right, next page. Take everything away from you. And let's.
Y is the midpoint of XY with the hat on top.
Okay, so number 1, Y is the midpoint of segment XZ. Given. If they give us something about midpoint, what should our next line be? Definition of midpoint. What does the definition of midpoint say about that segment? XY is equal to YZ. All right. So if XY is equal to YZ, then we're trying to prove that XY is equal to 1/2 of XZ. So XZ is what of our picture? XZ is what of our picture? The whole segment. So Statement 3 should be, we got to build that whole segment at some point here, right?
X, Y plus Y would equal
Yeah, segment addition postulate. Can write segment addition. You don't have to write the word postulate.
Okay, I feel like there needs to be a 2.
Okay, what could we substitute, Jacob? I could substitute YZ with another XY. Because up here, XY is equal to YZ. So we're going to replace this YZ with an XY. So that would give us XY. No. We don't have a segment subtraction postulate.
Why would you write X, Y twice and not 2X?
We only have a segment addition postulate. Can't do that. So we're replacing the YZ with an XY. And that's going to be by substitution. And then on statement 5, XY plus XY would be 2XY. So what's our reason on statement 5 though? Simplify, yeah. So the math that happens is division by 2, but we know that we can rewrite that as 1/2 XZ, right?
Yeah.
And that would be division. Is it? What's the proof statement say? That's exactly what we got written here. So that's it. Okay. Not too bad. Y'all did pretty good on that. Some of you see it, and then some of you are getting there. We're going to get there. Let's try number 11. I think we got time. Let's try. You can. Since they're AC, I think you should just go ahead and get them out of the way there for this one. AC congruent to DF and DC is congruent to DE. I'm going to make that clear that that's an F and not an E. See if you can finish this one.